Hello, everybody. Welcome to the conference. It's the second introduction after Nico gave a nice introduction before our dinner. So welcome. The goal of this 2-day, it's more of a brainstorming than an actual meeting. And it's actually initialized mostly by those two people, and I kind of shipped in from the software side, is to find out if we can decide on needs for a framework, for an open source framework, for high-end open custom microscopes. What would be needed from the view of the developers, from the view of the software people. And I also want to introduce myself a little bit. So for people who don't know me, I'm Stefan. I'm actually working here in SciComm. I lead a team of computational method development. And I'm kind of an outlier in this group. I don't come actually and build microscopes. I do more the downstream analysis. And I have still a lot of things that kind of disturb me about the way how things go right now, which is all things like how the data is stored, how the feedback loops are being implemented, how this is possible. And that's kind of the side that I come into this meeting that I want us to think about. What do we need? How should we do this, right? And the goal of the whole meeting is to really, hopefully, agree on a certain framework, to write a little white paper, 1, 2, 3 pages, where we write down what we actually want, and then see if we can get, apart from most of you hopefully shipping into this project, to also get institutional funding for this of some sort. Right? That's the big goal of this whole thing. So that's what we should focus on. We should find out what are the problems that we all share, what are potential solutions, how should this software framework look like, and we have the number one expert, Nico, here, right, who engineered Micromanager, has a lot of background in this, and I think it should build to some extent of this, maybe not, but something we should discuss, right? And I'm really looking forward to these 2 days. I also should say that from the Janelia side, I want to thank Janine Stevens. She helped a lot setting all of this up, so we actually didn't do so much. All these dinners, everything here in the room was done by her. Thanks a lot to her. And she also asked me to remind you all that please be respectful to each other, be nice. That's something that is Janelia policy, and I don't think I have to say this, but I was asked to kind of remind people of that.
Yeah, and in addition, would there be any issue, please contact one of us, Stefan or Janine, directly.
Yes. And yeah, and then we thought we all introduce ourselves a little bit. So I did.
About the recording first?
Oh yes, the recording. So as I sent already an email yesterday, we want to record everything and then cut a little bit, especially brainstorming sessions, and kind of put also the stuff on later on YouTube or whatever platform. Does everybody consent to that? Or does somebody not want this? Is easier. So that also means we can take pictures, we can tweet. You all got the Twitter hashtag too, right? So if you tweet, it would be nice to use this just to create some, energy for this, and yeah.
All right. Thanks, Stefan. And I'm super excited actually to have a chance to meet all you people I think I know, I really don't know, but we'll get a chance to know in the next few days. This is obviously a topic of interest for a lot of us. But going to conferences and all, we never really get a chance to chat about this. It's usually left for hallway conversations in between sessions. This is our chance to really dig down and talk about our likes and dislikes about the software we use, the choices we've made, what we'd like to see in the next generation software. And I have my user experience that I bring in. I develop optical microscopes, so I'm kind of on the consumer side of either LabVIEW or Python, whatever, Micromanager, these kind of frameworks that drive the microscope. And a lot of you are experts in writing your custom software or dabbling with Micromanager and whatnot. Be really curious to hear your experiences, your teaching moments, and what you'd like to see in the next-gen software. And like Stefan said, we'd like to converge on a few things that we all can agree on, and hopefully with that momentum go forward. And then develop something in the open that we all can contribute to, debug, share with one another, and so on. I think this is a very exciting time, and I'm really hoping for a positive thing to come out of this. And with that, I would like to give it over to Nico.
All right, thank you very much. Yeah, let me, I think I'll start the presentation right now, and also kind of to help frame the whole thing. So in my mind, microscopy for a long time has been a very interesting field in the sense that we have scientist users who want to use the microscopes, and most often they will work with some kind of commercial microscope system that has been packaged nicely by a company, so that a cell biologist or a biologist can easily work with it and get the kind of data out of that they would like. But also, on the other hand, we have microscope developers, and there are quite a few amongst us here, who develop things like, well, this is an image of a lattice light sheet microscope, but you can replace this with any of a cool advanced system that just by virtue of them being experimental systems, of like developing in the lab, do not have like an easily accessible software interface. The software interface most often will be designed by, written by people who either, who just want to make that thing work, want that microscope to run, want to get everything out of it, but are not really directly concerned with bringing that back down to those cell biologists. So there's a big difference in accessibility, and kind of the normal route this takes is that you sell the concept and ideas of that advanced microscope system to a company, you wait a decade, and then something will appear on the market that is still not as good as that thing there initially. And so in my mind, so I think what all of us would like, we want those systems to be out there and we want them to be used. And one big chunk there is actually having usable, user-friendly software that can run these systems. But on the other hand, also as microscope builders here, what a pain and how much work it is to actually write that code and create that code, even the experimental code, to run these microscopes. So there is a big gap in my mind of easily shareable tools that all of us can reuse to make these advanced microscope systems directly accessible to everyone. And then kind of as a third category, and I see myself and our lab much more there, is more like the tinkering with systems. So take a commercial system, do something with it that you cannot really do directly with the commercial microscope plus software, but give your lab abilities that just extend a bit from the normal, but let you therefore answer interesting questions. And here you're dealing with the exact same problem. You need, it's all software. So I think we're all on one page here. We have need for software control of microscopes. It's very clear that that is not an easy task. It's also very clear that the components, the parts to easily share and work with each other are simply not there. And so I'm now going to tell you a story about Micromanager, but I really want to place that as more an example of a similar project. Micromanager has certain things to offer to this problem. It's definitely not the solution, and I also don't want this meeting in any ways to have the focus to, do Micromanager or something. I just want to give you here kind of the thought processes, the hurdles, the choices we made, and a bit of an overview of what is there and what is involved in, having a software project that you literally push out to thousands of microscopes and have working in many, many different labs. So Micromanager kind of started in this area here, the Bay Area. This is a view from the top from Mount Tam. And I'm showing this not only because, I really like this place and I like living here, but also because this is actually a view of one of the sites where our lab has a bi-yearly retreat, where we're basically challenging ourselves to come up with new ideas and new things to think about. And our lab is really a group of biologists, biophysicists, that does venture a little bit in building things now and then. And so all these ideas came from all these people, and these are all pictures of the lab through the years, through the like 15 or more years that I've been part of the lab. So, that's my efforts into Micromanager, the prime focus was really to help these people do science and get somewhere. And so it was at one of those retreats back in 2005 that a graduate student, a postdoc, and I proposed this idea. We were at the time, we were running some commercial software on some microscopes. Every microscope runs something else. One software package was shittier than the other. It was painful to have to teach everyone different software packages at different microscopes. And so the three of us said, like, well, we can do this better. We can write something. We can make that open source. We can make that freely available. And we can run all our microscopes in the lab with it. We can share it with the world. And we can do that in like 3 months or so. And Ron was smart enough to jump into that and say, well, guys, that's a good idea. But you really should get someone who knows what he is doing. And we thought we knew what we were doing, but clearly we didn't really. And so basically, when you come up with the different strategies for software control of microscope at that point, you can write something completely from scratch. And there are quite a few people here who are doing that. So Loic is writing Java-based. Andy is using Python to talk directly to the hardware, do the whole thing. There are definitely more here. And there, also all the commercial software packages that we know started in labs like this, evolved, were brought out in a company, were bought. So basically that gives you the fullest control possible, but it's also most effort and highly time consuming. You can then use what I call toolboxes here, things like MATLAB and LabVIEW. So we see here at Janelia that most of the systems run LabVIEW. That takes away some of the pain of the actual writing hardware drivers, but you still have to put that whole thing together the way you want it. Or as a lab, you can buy commercial software and hope that it's going to do what you want. And so, of course, the latter thing is much less flexible, but it may, if it works, then it's by far easiest for the biologists. And so our hope was to kind of like slash right through this equation, make an open source, freely available tool that you can use as a toolbox and that everyone can use. We were and we were at that point lucky enough to actually find Nenad, who is back in the room here, who had previous experience in industry and kind of knew what he was doing. And so all we told Nenad in the beginning is that we wanted this thing to run under ImageJ, and the reasons for that were back in the day very clear. ImageJ was what all the cell biologists are using for their image analysis, image viewing, plus the hope was really that ImageJ would take away a lot of the pain that we have in visualizing images, in saving images and whatnot. Nenad was always a little bit reluctant about that part, and I've kind of come around to him as well, but we'll talk about that more later. So Nenad came up with this design where he abstracted the hardware in what we call a core. They are then pluggable things that we call device adapters that are pieces of C++ code that talk to the actual either device drivers or serial ports. So those things talk to the devices. If you want to go to a device, you have always to go through that device abstraction layer to keep these things clearly separated. That whole lower part was written in C++. And I have to say that like now 15 years later, that bottom API still completely stands. So the idea is that you have like any device can declare that it has a certain number of properties, and those properties can then go all the way to the user interface, and the user can change these properties of these devices. And then, you know, a device like a camera can of course give you images, so there's specific functions for a camera. There are like stages, and there are a few other device types. But so it's always pretty clear. If you want to write a new device adapter for a new device, you match that up with what is there, and you basically write the glue code to make that thing work. And so by making that relatively easy and straightforward, in the beginning, Nanad wrote these things, I learned how to write them, and then in no time, once Micromanager became slightly more widely used, we started to get contributions from academia, contributions from companies, and the list of device interfaces, device adapters is, to me, kind of stunning. It's like a huge number, and the great thing with that is so people can just write this thing, plug it in, and it works in this whole software package. And so for a lot of like smaller companies, it's a godsend because they can now sell their devices because people can actually use it together with other devices. And so we've had also quite a bit of buy-in from industry. So including Hamamatsu, PCO, Endor, Photometrics are all writing and maintaining their own device adapter code. This part, in my mind, is really a big success, and I think that's also something that you know is certainly worth continuing. So you know, count more than 100 authors, and it keeps on growing. And what I learned from this is that well-separated interfaces are important. When you can describe this to people and do that well, they can just go off and like add functionality without interfering with the rest of the system. And the other thing that I kind of learned from this, you know, C++ may be hard for a lot of people to write, but you know, that code is going to survive, and it's going to survive for a long time, and it can be used from any other different programming language. So for you know, those things you want to live long, I think it's a great choice. But those are all things we should talk about. Nanad also then, he exposed that upper API from the core to the Java environment, because remember, we wanted him to work in ImageJ. We came up with this kind of interface that works everywhere with every microscope, and this whole thing was developed with people from our lab. It literally was like, you know, figuring out how can people in the lab actually most easily work with this? How can we keep things simple and straightforward? You know, a snap and live button top left where, you know, that's the basic functionality you want, all those kind of things. And, you know, of course, user interfaces, there are all kinds of tastes and whatnot. I think we succeeded to have this work for cell biologists. Now that that intermediate Java layer, I think was less structured initially, and we learned a lot. So that has been over time kind of more solidified, and by now there are decent APIs within that Java layer. And I would like to, you know, I kind of see there are 4 different parts: the data viewer, data storage, an acquisition engine, and then a plugin interface. And I want to go through those consecutively. The data viewer, so I thought this was going to be a shoo-in because ImageJ was already, you know, you just pump your data into ImageJ. That ended up being completely not true, and that ended up being a complete nightmare. And over time, what has been happening is that ImageJ interface has been encapsulated more and more, which was a wise decision, and is now like ImageJ is still drawing these things, but it doesn't really even know what image it is showing. And so, and that was all for, sane programming reasons. So by now, that data viewer, I personally like it quite a bit. It's, multiple axes, you can loop and play through these things. There are live histograms, you can graphically change brightness, contrast, there's gamma, there's access to, you can put like size bars on, timestamps, you can see all the metadata everywhere at any point in time. And so, over time there has been an insubordinate amount of time has been going into making that viewer look good. And here I want to do a shout out to Mark, who was the last one to really separate this out from a lot of the ImageJ code. The data storage is a bit of a similar idea. I remember that Nenad and I talked to the OME TIFF people, and we were asking, well, where's a library that we can just start writing files? And then there was no library, and we were kind of just on our own. And we've also gone through, various iterations, figuring out what is now really the best way of doing that. And in the meantime, we're under pressure from the camera companies because they want to write 100 frames per second, 2K by 2K, 16-bit. And so, all these, and so at the moment, and I'm certainly not saying that this is the ultimate best choice, it's just the one that historically grew. But Henry played a big role in this, in writing this multi-page TIFF format that stores the micromanager metadata, the OME metadata, the ImageJ metadata, and you can more or less open it everywhere, although it has all these funky things because it cuts it off after 4 gigabytes and does it in chunks because it doesn't do big TIFF, and blah, blah, blah. The good thing is that by now this is all relatively well separated out, so other data formats could in principle be put in there. But here I feel like also as a community, having readers and writers for data formats that we believe in, that everyone can use, would really be the path forward, because they keep on doing this as individual efforts is not going to cut it. Then the part that kind of is really micromanager's responsibility is what I call here the acquisition engine. So it's the sequencer, it's the code that the user tells to, hey, I like a time lapse, I want a Z-stacks at time point 1, then I want to do that at different positions, and I want this and this. And then the acquisition engine goes off and talks to sets up the hardware to do that in the most efficient way. Arthur Edelstein played a big role in that. This is what the interface looks like that the user sees. This then sends off a protocol to this acquisition engine. It knows about timing of devices to a certain extent. It knows a bit about hardware synchronization. So we have a simple model where the camera can send triggers to devices. And so things like triggered Z-stacks can be done very fast if everything is configured right. And the acquisition engine can have that knowledge. It was a great effort and a great piece of code. The big downside of this was that it was written in Clojure. And Clojure is a language that translates into a Lisp-like language that translates into the Java virtual machine. And basically nobody can work with that, including myself. And so the problem was really that when Arthur left, there wasn't that much that we could do with it. And so that thing is still sitting there. So I learned, even though the language may look nice and awesome, just stay away from it. Just don't do it. Like, settle on what everyone can work with. Now the plugin interface. So for me, that thing has been a big joy. So I've written quite a few, and for me it's a lot of fun because then here you can really start doing creative fun things with your microscopes. So this is an example of something that a postdoc in our lab is now working on, where she is with a Galvo device is photo bleaching these moving particles. So there's a projector plug-in that calibrates the Galvo to the camera, and where you can then fire your laser at specific intervals. But then that is coupled with code that takes that data, analyzes it, sees where those bleach spots were, and then comes up very rapidly with bleach curves and kinetic data about these particles. So, you know, the great thing for me is I can set up a workflow that people can do things that otherwise would be close to impossible. And well, another example of this is this localization microscopy plugin that we wrote ages ago, and I thought that the Storm Palm people would really like that, but nobody really ever fully picked up on it. Our lab does a lot of single molecule tracking, so there's also, that stuff is all built in, and at the moment we're actually getting a lot out of this because we also put this 2-color registration in here. And so a student in our lab, Stefan, worked this up to nanometer, to a system in which he can measure distances between 2 single molecules of different colors at nanometer resolution. And so that's all pushed in here, where, you know, retroactively, I don't know if this was the wisest decision. For me, it's just very easy because I put it into the Micromanager source code and it gets built and people can use it immediately. But this was kind of a pain to maintain for myself. Another one I want to mention here is Sharona Shawn, who is in Jonas' Reese's lab at EMBL. So he has been working on kind of a way that you can, with a small file describing a user interface, pull that up in Micromanager, and apparently they're using this to operate their microscopes, so to bring up panels that are matched to their specific microscope and have user interface elements that work for them. And so that is also a plugin. Yeah, that brings me to support. You know, all that work is completely useless if you don't interface with people using your software. There are various, I think, aspects of this. One thing that I've always found important is to have a simple installer. So on the Mac, you drag the application to the applications folder. On Windows, there is a normal installer, where I have to say we have to work on signing these things. We have totally stayed behind the times. You know, another big one here is email. So, and doing that through a mailing list, and we plan to move this now to the image forum real soon. But having a central place that people can ask questions and that is archived and then later can search is essential. And there's still quite a bit of traffic there. And one thing that is important is to actually answer these questions, which for whatever reason I kind of like doing most of the time. So you know, it's just nice if you can help someone and get over that hurdle. Other part of it is the website. So we set up this wiki-like thing and encourage everyone to edit that, which happens to some extent. It's still a rich form of documentation. I don't know if Google is cheating me, but usually when I search for something microscope hardware related, it brings me to this website. So, and personally, you know, I don't remember everything either, and just look it up here. And then what also has been super useful is something that Mark built, and is this built-in reporting a problem. And basically what that does is that it starts some logging. So you repeat the actions. It gives a huge output about the whole system. The user can then send that. It arrives by email to us, and that often helps to figure out, okay, this is the thing that is not working for this person, and either fix it in the code or give that person advice on how to set up the microscope. Now, so what is the impact of having all this and having put all the effort into it? It's a little hard to actually measure how many people are using Micromanager, and we're using a couple of different measures. One of them is these registrations. So when you first start it up, it asks you to register, and even though you can say, well, I don't want to do it, still plenty of people do. And so that number continues to grow pretty linearly at the moment. We're also kind of tracking in Google Scholar how many articles are mentioning Micromanager, and that is because a lot of people don't cite it, but they do mention that they use it. And so that is now currently somewhere over 4,000 or so. And we also, the three publications on Micromanager were cited now roughly 2,000 times or so. We have some data about how many people use these systems with actual hardware, and that is on the order of 20,000 or more that actually made it onto our servers. So, you know, it is clear to me that there's impact, and it's clear that quite a few labs are using it and relying on it to do their experiments. It's almost a more interesting question at this point in time, what the type of users are. So I think there's a significant chunk of people who could also have used commercial software to run their microscopes, but they don't want to pay $10,000 for software that just grabs images from a camera and that opens and closes a shutter for them, because that's often what it costs for something simple like that. So to be honest, I am totally happy to help those people and make sure that they get somewhere. But in a way, the more interesting part is still in, you know, people doing creative things with it, and like the stuff that I'm doing with it. And luckily, you know, it is quite clear that there's at least a number of labs that are doing those kind of things, and some of those labs are here, which is very cool to me. And so enabling those kind of creative approaches and new approaches is what really, where I see value, or what gives me most joy. And, you know, I kind of want to mention a couple of projects, bigger things that were built on top of Micromanager. And one of them is this open SPIM that originated from Pavel's group, who was going to talk here. Where they have a kit or had a kit. I don't know how well this is still maintained or running, but the design is still online. So there's a kit of parts you can buy. There's a video of how to build this thing, and then this then runs on a slightly modified Micromanager version. Kind of similarly is this work by John Daniels from the company ASI. So ASI is building the parts for the dye SPIM that Andy York, then with Harry Schroff, came up with as a type of light sheet microscope. So John, and it was kind of prompted by me, I thought this would be a great way of showing what you can do with Micromanager, and I started with this, and luckily John picked this up and he really made this work. So he made this elaborate Micromanager plugin that runs that dye SPIM in all its various different forms and really makes that go at hardware speed. And so he has been helped a lot because they're also doing the electronics themselves, and he has the interface. So they have complete control of that whole system, and they can nicely package that so that it really works well, but it also works very easily for users. So I've trained people on this in, like, I don't know, less than an hour, and they're ready to use this pretty darn complicated microscope system. Yeah, likewise, Bin, who set up what they called The eSPIM, I don't know, this goes all with all kinds of various different names. I don't know what I should call it these days. I kind of see this now as a predecessor of the Mr. Snouty microscope, but I don't know. But in any case, so they didn't want to really deal with the software. They wanted it user-friendly, and I helped Bin run this in Micromanager in, I don't know, one afternoon. We had this whole thing going, and it seems to be working nicely without many issues for them. Henry, who is here online, built this very elaborate Micro Magellan plugin, where you basically send off the microscope to image large 3D volumes. So you take images at all kinds of different positions. He has all kinds of cool things of setting borders and whatnot, and a pyramidal data system, so you can zoom in and zoom out and work with large data sets. And he also has very recently been working on building a bridge to the Python world out of this Java application using this thing called ZeroMQ, which is a library for very fast communication between different applications in your computer itself. And that seems to work pretty darn well, to the point that you can, in Python now, get the whole Micromanager API easily accessible. And so that I see a lot of interesting applications with that. Project I want to mention here is a graduate student in our lab, Xiaowei Yan. So she is working on a project to mark specific cells on the microscope. So we have the microscope go around, recognize cells by phenotype. For instance, you want cells that have a large nucleus. So we start imaging. The analysis code finds the cells with the large nucleus. We then also express a photoconvertible protein in these cells. And we now, on a DMD, shine a mask on that cell that has the large nucleus, photoconvert this fluorescent protein, and then later, after the whole experiment is done, we harvest all of them up, and Xiaowei can then fact sort out the positive cells to see, to get her hands on that cell with large nuclei. Now, it's an elaborate system that has both the component of the DMD control. There is so we have a DMD sitting on the microscope, and there's then a plugin that is basically taking care of the analysis and this whole process, and that is also all running in Micromanager. And that system is working successfully. I thought that nobody would be as crazy to do something like this, but then there is a BioArchive preprint from late last year from a group at Washington State, where they did something similar, and to my dismay, they actually had done this in Metamorph and using Metamorph journals. So clearly it can be done. The only thing I can say, we had a lot more fun than they had. How did we keep this whole thing floating? So I think that is a big part of all of this. And to be honest, it always has been a struggle to keep it alive, even though the benefits, I think, are pretty clear. So it started with a small internal UCSF grant from the Sandler Foundation. We did manage to get 7 years of R01 funding. It was very clear in the renewal that NIH was not going to continue this. This was going to be the last. I think that overall, well, you probably all have your own experiences, but it seems to me from the outside that the NIH is not really interested in funding these kind of infrastructure projects. I around me see funding for these kind of things disappearing everywhere. Everything has to be innovative, even though you need tools to innovate. We have ventured in other ways, other solutions. So we've been involved in 2 different companies, 100X with Nanat and Open Imaging with Mark. And I think one of the big problems is the tension between wanting to bring out free and open source tools and running a business. Plus running a business kind of distracts from what you really want to be doing, and that is writing that software and working to make these tools. So, you know, even though it may be possible to do this, I have not seen that as a happy direction. The nice thing is that Mark, who regretfully is not here yet, has found there he is. Ah, good. Has found a home at the University of Wisconsin-Madison in the group of Kevin Eliseri, and even has been awarded a grant by the CZI. And you know, I think that in the end, and also for this forum here, the hard situation is that projects like this seem to only be possible with money from private funders, and those seem to be the entities willing, and I hope they continue to be willing to support these kind of efforts. Okay, so that's where I'm gonna leave this story. I first of all want to do a big shout out to Ron. So Ron has been super supportive of this project from the very beginning. And he has always been on the lookout to see where he can help. And on top of that, even though he sometimes told me I should not be working on this, he still has let me kind of continue making sure that it's kind of alive at the very least, and closed his eyes when he needed to close his eyes. So thank you, Ron. I also want to thank all the members of our lab. So a lot of them have been heavily involved in developing this software, in beta testing, coming up with the name, coming up with ideas. And plus, that has been just a wonderful, great environment for me to be in and have this group of people to help run microscopes. And then there's a wonderful group of people who have worked on Micromanager over the years. And you know, on top of that, one of the great things for me also is that this project has had so much reach in a large community, both of people using it, people contributing code, people at companies, and all these collaborations and this whole network that kind of built around it, to me has been a lot of fun to be part of. And that's where I want to leave it. I'm happy to take questions, but it's a little funny, maybe. But
So questions?
What's next? What's the future?
that's what we hear about. Yeah, I think, you know, Micromanager itself kind of has its own path. I think that kind of the exciting thing is a little bit to step beyond that. You know, we learned a lot. We made mistakes. All of us here learned a lot. There's clearly, you know, it's clear that not everyone is using Micromanager because there are deficits, there are things it's not doing for us. So what can we together come up with whatever name that really will be beneficial to all of us? What can we, you know, envision? What should we build that really will move things forward? That is, yeah, what I would love to see coming out of this meeting. So well, we can start now, but maybe better tomorrow, or at the bar.
So I guess
Fro.
We have a mic here.